A request for help came in on the Titans of CNC forum on Facebook, and this one came from Andy, who was looking for a little bit of help coming up with a good pattern to slot out the inside shapes here. Now, this is the file as he sent it to me, and you can see there's some issues going on. Basically, what was happening here is he's trying to come up with a pattern based on this floor surface that you can see, and basically staying inside of the walls. Now, I would argue that we probably want to mentally separate what we're trying to accomplish here, because we want to deal with the floor surfaces, but the walls themselves may actually need to be swarfed as a separate finish toolpath, but we'll deal with that in a minute. Now, he has a set up here with a 5/16 end mill, so 0.3125, and this is running into some issues here. There's some noise in the toolpath down on the bottom. The pattern itself we don't necessarily like, and of course there's a bunch of retracts and other things where it's kind of gouging into the walls. Now, there's a lot of options set, and I don't want to go through and deconstruct every step that he took to get here. So I'm going to start with a clean, unified toolpath just to put something on here. So let's go to toolpaths. We're going to go unified, and I'm going to choose tool number 11. But before I do anything at all, I'm going to come right up here and I'm going to reset to default so we can talk about what's going on step by step. So let's go here, tool number 11. For my cut pattern, I'm going to choose automatic, and that should take this boundary and create something good. So let's do machining boundary, or machining geometry. It's just going to be that floor surface. And I'm going to set my maximum step over to 20 thou. I'm going to leave everything else alone until I see what I get and, see if I like it. Same thing, tool axis control, just leaving that alone, and I'm just turning off collision control by default. Nothing should be gouging here because I didn't select the walls or anything, but good practice to just turn that off and see what the pattern is. Now this is saying only spherical tips are available for center. I'm going to tell it no, I don't want to calculate, and let's talk about that. I think I covered this in another video, but basically when you're in unified automatics mode or specifying guide chains, you're using the geodesic algorithm. See my other video for an in-depth discussion on that. But basically the long and the short of it is that if you have a spherical mill or a lollipop, something else with a ball there, it will puff out the corners and basically prevent it from gouging full stop. However, it can't do that if you have a flat end mill or a bull nose or any of the other shapes. And this is what it was complaining about. So it was just saying, hey, you used a flat end mill and you were trying to use tool center mode, which is the default. Would you like to switch to contact mode? So I could have just hit yes and continued, but I wanted to explain that. So let's apply that now, see what we get. I'm going to slide this out of the way while it generates that toolpath. Okay, hey, look at that. Beautiful, beautiful toolpath right off the bat. But of course, this doesn't necessarily solve this problem. So it looks pretty on the screen, but of course the reality of it is that as we look at it, it's cutting right to the center here. Now, also the linking could, of course, be improved a little bit, but as you know, we deal with linking last. So let's deal with this first problem of the tool plunging through the wall. Why is that? Well, it took this flat floor surface and it's trying to create a boundary like a chain all along the outside edge of it, and it's now taking that chain, and as you can tell from the pattern, it's creating an equal scallop style, or geodesic you could call it, pattern from the outside in, which is a beautiful toolpath, but we don't want it to start out here. If we try to solve this problem by throwing collision control at it, we're going to be in for kind of a world of hurt, because the exact thing that you'd want to fix is a little different right over here than maybe up here. The best you could hope for in this one would be to trim off anywhere that it touches the corners, but you're going to find yourself in some weird situations where it's like trimming off half of this pass, but not a bit of the other one, because of course it's all just a tolerance thing. It would be better if we could just avoid it as part of our pattern, and luckily we can. So I'm going to head back into my parameters, and let's take a look at the options that are available to us. I'm going to expand my cut pattern. Now, we were already talking about this, machining geometry contact mode, right? But let's talk about the guide curve and the containment. So even though we didn't actually specify a specific containment, this toolpath has one already because we told it automatic mode. It's taking that outer profile and it's creating this map that it's trying to stay inside of. But this same exact problem, and I'm sure you've ran into it if you've ran 3-axis toolpaths like either OptiRough or equal scallop, you run into this toolpath control issue where you choose the upper edge of your surface or your boundary, but then it walks the tool up because it's trying to compensate to the center. The center of that tool is staying at the boundary, and that's exactly what's happening with this Unified. If you were an equal scallop or opti or something like that, you'd compensate it to the inside, right? Well, let's look for that equivalent in here. Oops, sorry, didn't mean to keep that toolpath. We don't actually want it. Let's come over here, and we're going to come into our containment, and right here, this tool mode, we could choose whether we want to be outside the containment, whether we want to be to the center, or whether we want to be to the inside. Now, one thing you're going to find in Unified that's different than the equal scallops and some of the other ones. Remember, this is a different engine completely. This is the ModuWorks engine. So if we do the inside, you do have to give it your radius, right? So we have a 5/16 tool, so we're just going to divide that by 2, 1/562. And that's pretty much it. So now let's just apply that. And there we go. Look at that. All right. So now we've got this toolpath let's just watch what's going on here. Now you see, this is what I was talking about, where normal to the floor is not swarfing the wall. In fact, I'd probably recommend that we don't actually use a bullnose or a flat end mill to do this shape. I don't know that you're going to get great results because, of course, you're running into issues with where do you actually want the tool contact to be. So I'd recommend either a heavily bull-nosed end mill or maybe even better would be a small ball mill probably to do this. But as you can see, we're now getting that toolpath coming in and following the walls. Great. So as we follow this around, let's go down and check some of our other settings. Now that we're happy with the pattern, we could, of course, set everything else. So let's go and turn on tool axis control. Now, I believe this is being done on a 4-axis machine, so we're going to set our toolpath to 4-axis. And I'm going to make sure that my 4th axis is set to my X, which is appropriate for this. So apply that. All right, well, that made it look a whole lot uglier. Now, what's happening there? So as we come around, let's just follow one of these patterns that gets ugly. So I'm just going to choose this one. So you see that the tool's kind of moving around a bit. Well, because we locked it into 4-axis mode, it's actually bouncing back and forth, trying to keep that different parts of the tool in contact for that individual vector. Now, if you change this to a ball nose end mill, you're not going to see that because it's not bouncing around on the flat of the tool, right? So let me just make a real quick 5/16 ball mill so you can see what's happening here. 5/16. I'm not going to set any other settings because I don't really care. Let's sort this by tool number. Okay, tool number 13, green check. All right, so now, of course, going to a ball mill, you don't see that noise coming up because it's not bouncing around kind of front to back. And that's what you were seeing before, is it's, bouncing from the front, the front of the flat to the end of the flat. Now, what happens if we still want that 4-axis locked motion, because this machine, of course, can't tilt, but obviously this motion is just, straight unacceptable, right? We really don't want a tool doing, oops, let me just change my view a little bit here. We really don't want a tool reacting like this just because it's trying to keep different parts of it in tangent. Well, in this case, this problem was solved by tool axis control, right? The toolpath looked beautiful until we tried to lock that tool to 4-axis. And what's happening is right now, it's running the tool just at automatic mode. So it's free to tilt the tool any way that it wants to, as long as it's obeying the fact that it's 4-axis. So what we're going to do is we're going to tell this thing, cut with the center of the tool. And let's just watch what that does to the pattern. Hey, look at that. Our pattern's back. Yay. And why is that? Well, we're now using the center of the end mill to do the cutting. This is going to cut along on here, and you can see the contact stripe is down here. Now, obviously, you need to make sure that you've got a center cutting end mill to do this. But again, I would highly, highly, highly recommend that you do not use a flat end mill to do this shape. It's just, you're not going to be happy with the results. It's not going to look great. You'd be much better off doing a ball mill or a heavily bull-nosed, end mill to cut that so you get some nice scallop there. A couple other things to clean up here. Obviously, our linking's a little ridiculous, so let's just clean that up while we're in the toolpath here. So come on down to linking. What's happening? You got a little bit of blend spline action here, which is probably okay. That's fine for the small links. The large gaps are retracting to clearance area. That's probably not really needed, but we'll just let it go. The clearance area, we're just going to set that to a cylinder along the X. We're just going to run it through the center through automatic mode because this is a round part and it's easy to figure out. And maybe 1.5 inches now. How did I know that? Because previously I had measured the radius of an arc and chose one of these. There we go. Cool. Green check that, and we'll just see what that looks like. Should tighten that up a little bit. And of course, what we could do, yay, that looks better. I don't want it plunging straight down, especially for center cutting. So we're just going to add a lead in, lead out, and see how that looks. There we go. Now those lead in, lead outs may be a little big. Honestly, they look like they'd be just about fine, so we could leave them in there. You can adjust your feeds and your speeds and all this stuff, so this is a small part. Maybe the rapid distance could be like, 0.25 instead, and the entry feed could be 50 thou. Cleaned up a little bit to make it happy for you, but there you go. That's how I would attack this for the roughing path. Now, if you did want to finish this thing with the sharp corner mill, we could do a Swarf milling toolpath. I think would be a better choice for you. So let's put one of those on. Let's do a cut pattern. We're going to say that we want to Swarf. Now, unfortunately, I think we're going to have to select this manually, and there are going to be two separate toolpaths because this is one side over here, and of course we've got the other side over there. So I'm going to have to manually select this. Now, had these been different colors on this solid, then we'd be able to get away with it, of course, but c'est la vie. Okay, there we go. Now, the floor geometry, of course, is that one. We're just going to leave 0 on both of these things. I'm going to try and just see what automatic mode. Now, oh, I see. There's a lot of other defaults set here, so let's just set this back to defaults and make sure that we're happy with that. So tool number 11. And so it remembered my cut pattern and my floor. And I just want to see what I get in automatic mode before I do anything else. So let's see what we got. So, probably want to turn on some lead in, lead out, but overall not too shabby. Now we can make sure it's set to 4-axis and that it's not doing anything bad. So let's just see what that does. And I wasn't expecting anything too bad here. So everything's pretty much behaving itself as you'd expect. Yep, looks good. So that's how I would machine this part. Hope this helps.